All right. So yesterday we talked about the steps of the scientific method. We also talked about what they all mean. Today what we're going to start with is looking at an example of how we apply these steps to an actual real-life experiment that we can do. So this will help us to review what the steps mean as well as understand them. All right. Problem. This is the step in which you ask a question. Problem always phrased as a question. So in our example, we're going to ask a question. And the question that we are going to ask is, do mice gain weight if they are given extra vitamin C? That's a question we could ask. Could we answer that question using an experiment? Yeah, we definitely could. And that's what we're going to be talking about. That's what we're going to be using as our example. Okay? All right, before we can move on, we need to know a little bit about these subjects before we can set up an experiment. That's the research step. What kind of things would I have to know? If I was going to do this experiment in class tomorrow, what is some research I would have to do before I can set it up? Grace? Yeah, I'd have to know what mice eat, what mouse food is like, where do I get it? Rihanna?
Like how much vitamin C they get not like in their normal food?
Yeah, how much is like a normal amount of vitamin C for the mice? What else would I want to know?
What's their normal weight?
What's their normal weight? How do I keep mice? What kind of bedding material do they get? What are the different types of mice? There's a lot of things I would have to know as I'm setting up this experiment. Sort of background information. How can I get vitamin C? How do I give it to mice? I'd have to learn all of them. So that's the research step, background. Once you have some of that information, you can then move on and come up with your hypothesis. So your hypothesis is your prediction about how you think the experiment is going to turn out. So what might a hypothesis be for this experiment? Sophia?
Mice cannot gain weight given extra vitamin C.
Can you say, no, I don't think they will gain extra weight? Is that a valid hypothesis? Yeah, definitely. Can you just phrase it? So you remember how we said we could phrase a hypothesis, like using a certain pattern? If something, then something. So Sophia was fine with her hypothesis, but if we rephrase it, it'll be a little bit better. If mice are given extra vitamin C, then they will not grow any larger. Okay, that would be her hypothesis in the form of an if-then statement. I wrote up there that they will gain more, but either one, you could leave yours. You don't need to. We could say they will gain more. We could say they won't. It's up to you. It's your prediction, what you think. And then I have to set up my experiment. Our experiment's purpose is to test what? What does an experiment test? Jenna?
To test the hypothesis.
Test the hypothesis. So can you envision a way to test that hypothesis? Does anyone want to describe to me? How would I set this up, this experiment, to test this hypothesis? Jordan?
Take a mice, put the mice in like a container or something with vitamin C, and then release it.
Okay.
Did they gain more?
Okay. So Jordan said I'd take some mice, put them in a cage, give them extra vitamin C, see how much weight they gain. But I'm seeing one problem there. Ava, do you know what the problem is?
There's only one mouse.
Okay.
So if you were giving extra vitamin C, you would know. So like if you get two mice, you give one extra vitamin C and one his normal food.
Okay.
And then if the one who had the extra vitamin C gains with more weight, then you'll know it's true.
Okay, does that make sense, Jordan? Because if you just have one mouse and you give it extra vitamin C and then weigh it, well, is it larger than it would have been?
Yeah.
Do we know? I don't know. I need that other group like Ava just said. So when we have an experiment, we always have two groups. One group we set up just like Jordan said, where we have mouse, we give it extra vitamin C. But then we need the other group as well, like Ava said. What would we do to that other group, Ava?
Not give it any extra vitamin C.
Yeah, we would try to treat it the same as the other mouse, but it just wouldn't get the extra vitamin C. Then I can compare those two mice, and I can see, did the vitamin C have any effect? So in a good experiment, you also always have to have more than one group, and we'll talk about these groups in a minute. So we get two groups. One group of mice gets a normal amount of vitamin C for mice. The other group maybe gets double or triple or whatever. That would be an experiment that tests our hypothesis. So we have our mice. We have two separate cages. We're feeding them, giving them water each day. One group's getting double the vitamin C of the other group. We give them, I don't know, 4 weeks, 2 weeks. And then it's time for my next step, observations. What are we going to be observing about these mice? Mia?
You're gonna observe if the one group gets the normal amount, no, if the second group gets the twice as much to see if it is overweight.
Okay. So just give me something very short. It's in what you said. What would we observe about our two mice?
You'll compare
What would I measure? What am I measuring about these mice? That's all I need. So what are we observing? The weight of the mice. You're sort of getting a little bit ahead into the conclusion. So I weigh the mice. That's my observations, weighing the mice. After 2 weeks, let's say the vitamin C mouse weighs the same as the non-vitamin C mouse after 2 weeks. So I have my data. I've made my observations. And I'm on to the last step. I come up with a conclusion. In the conclusion step, you decide, well, based on these observations I've made, is my hypothesis correct? Or is my hypothesis incorrect? So the hypothesis I wrote here, what would your conclusion about it be, given this data? Brandon?
My hypothesis was not correct, and
Yeah, that's all we really need to say. According to this data, the hypothesis I have up here was incorrect. What about Sophia's hypothesis that she gave us earlier? That was correct based on this data. Is it okay that your hypothesis was incorrect? Did we still learn something? We don't need to change our hypothesis to match our data. We just say, okay, our hypothesis is wrong, but we still have learned some valuable information by doing this experiment. So this is how we take those steps and sort of put them into action. So as we go through this unity of quizzes and we're gonna do some practice worksheets and stuff, lots of times what I will do is give you a description of an experiment and then ask you, based on this description, what was the problem, what was the hypothesis, what was the conclusion, and so forth. We need to get into a little bit more detail. Well, I guess I should. Do you ever use the scientific method? Yes?
Yes.
Okay. You do. You all do. Some of you like to bake. So if you say, I wonder what's going to happen if I add some baking powder to my blueberry muffins. And then you bake them to see how they turn out. Is that an experiment? Sure. You have a hypothesis that adding baking soda is maybe going to make them lighter. So you conduct an experiment and you make them. You make observations when you taste them. Come up with a conclusion. So you may not write down all the steps and figure it out in this way, but really you're doing the scientific method. Okay? If you're looking at a new approach to dribbling the soccer ball, you might change the way you're doing things, and therefore that's an experiment. Lots of your gamers, gaming, you experiment by trying different things. Come up with a hypothesis. You familiar with this game?
Yes.
Yeah. All right. So, one hypothesis about how to come up with it is what? How can you get this thing out? Does it work? Okay, hypothesis rejected. Any other options? Move down. Observation. Did it work? Hypothesis accepted, but now I'm in trouble. Alright. So when you try to end this video, alright, now what do we have to do? Put it down there, and then you can make it right. Now what? Alright. Okay. Ready again? Alright, I have a problem. I can't catch them. Hypothesis? Go backward? Alright. So, we do an experiment. That's not working, so we do an experiment. We don't get backward. On the side. Alright? Observation, did it work? Yeah. Conclusion? Made a man. Alright? Alright? Alright, back. Alright, here we go. Observation? Alright. So, did we use the scientific method? Of course we did. Now, again, you don't think about it that way, probably. But it is the scientific method. Alright.
And now you use it to get to the next step.
Right on to the next. All right. Let's get into a little more detail about a couple things. Variables and groups. You guys remember the girl in the plant experiment yesterday? The color of the light, the amount of water, the amount of time, the temperature, all those different factors, we call them variables. A variable is just one factor from our experiment that we can measure, that we can change. So write that in, factors in our experiment. And we have three important types of variables that you're going to have to know about. And we'll talk about those three right now. So one type of variable is called the independent variable. In an experiment, the independent variable, it's the one thing that you want to change between your groups. In fact, I tell students, remember, you could remember independent because the I looks like what number? 1. It's the one thing that you make different between your groups. If you imagine the girl's experiment yesterday with the plants, what was wrong at first, the way she set it up? What was the problem with her experiment, Grace?
She used a ton of different things, like she changed a lot of them.
Yeah, every one of those variables was different. So we couldn't be sure which one was affecting our plant. But then we fixed it. Once we fixed it, what was her independent variable in the new experiment after we corrected it? What was the one thing different between her two groups? Jenna?
The light.
The color of the light. That was the only thing that we made different between those two. Okay? That was the independent variable. So the independent variable, the one thing you change, it's sort of the thing you're testing, the factor you're testing. In that case, we're testing how the color of the light would affect. You could sort of think of it as the cause. If you think about cause and effect, it's what you think is causing some kind of change. If we think back to the mouse experiment, what was the independent variable in that experiment? Independent variable in the mouse experiment. Everybody think about it for a minute. One thing that was different between our groups of mice. Eva, what was it?
The vitamin C.
Oh, sorry, I meant Eva. Oh, it's okay. Yeah, the vitamin C. The vitamin C was different. One group got extra vitamin C and one group did not. So that was the independent variable. All right. If only one thing is going to be different between your groups, well, there must be a whole bunch of things that are the same. Like in the plant experiment, we changed the color of the light, but everything else was the same. The temperature, the type of plant, the amount of time. Those variables that we keep the same are called variables held constant. These are the factors that are not allowed to change. We make sure that they are the same between our groups. So if you think to our mouse experiment, what would be some of the variables we would hold constant in that example? So we have our two cages of mice. One's getting extra vitamin C, one's not. What are some variables we would have to hold constant? What's one of them, Michael?
You would have to make sure that the one group of mice has vitamin C and the other one doesn't.
Well, that's different between them, right? So that's the independent variable. What do we want to keep the same between those groups?
They get the same amount of water, food.
Same amount of food, same amount of water. Jordan, what were we going to say?
Same cage, same weight.
Same cage, same starting weight, same species, type of mouse. So we could have a huge list. But all of those things are things we're trying to keep the same so that we're sure we only have one independent variable. And then finally, the dependent variable. In an experiment, the dependent variable is the data that you collect, the information you gather, the observations that you make. In the dependent variable, we don't know how it's going to turn out until our experiment is finished, right? You could think of it as the results of your experiment. So in the plant experiment with the girl, what was the dependent variable in that experiment? What data was she gathering? Data was she collecting at the end of the experiment? Brianna?
If the color of a light affects the growth of plant,
Okay, give me a little less. So what was she measuring?
the growth of the plant.
The height of the plant. Yep. We can always ask for the dependent variable. We just want a simple, what did they observe? What did they measure? How about in the mouse experiment? What was the dependent variable? What data would they collect about the mice? Yeah? The weight of the mice. The weight. That's the data they would collect. So the way I tell people to remember, the D in dependent goes with the D in data. The dependent variable is the data you collect in your experiment. Need it? Sorry.
So you cover up
What about this
the
one?
plant and, there we go.
All right, so we just had when Jordan and Ava were helping me out with the mouse experiment, we said we need two groups of mice. You can't just have one group, we need two. And so we have names for the groups. They're called the experimental group and the control group. The experimental group in your experiment is the group in which you're changing something. You're changing the independent variable. You're altering it. It's the one you're testing. So if you think to our mouse experiment, which group of mice were the experimental group? Sophia?
The mice that had more vitamin C.
Yeah, the mice getting the extra vitamin C, because we changed something about them. We gave them extra vitamin C. We treated them differently. We changed the independent variable for them. So then we also have a control group. Which mice were the control group? Jordan?
The ones that weren't in the vitamin C.
Yeah, the ones that just got sort of their normal diet, the regular amount of vitamin C. The control group is like the test run for just for a comparison. We say we keep them under normal conditions. We don't change the independent variable in the control group. And we have to have that control group because we need a group for comparison. Like we said, if we just had the mice and gave them extra vitamin C, well, we don't know if their growth is the same or more or less than mice without the vitamin C. All right. So let's just further talk about our hypothesis, then we'll get to an example. So what's our definition of a hypothesis that we're now using? We're no longer just calling it an educated guess. What is it? Your hypothesis is... Aiken?
Educated guess.
Well, let's...
No, not that. Like an estimate. An estimate.
Close, like this is mean, it's kind of, well, a little bit like an estimate. But we call it, yeah,
A supported estimate.
yeah, close, but I'm gonna use a different word than estimate. Claudia?
Prediction.
It's a prediction. So a prediction's kind of, an estimate's like a type of prediction. So a prediction about what? The weather tomorrow? No. A prediction about what, Rihanna?
What you think is gonna happen?
Yeah, what you think is going to happen in your experiment. That's what a hypothesis is. Okay? And a hypothesis in science has to be testable, has to be something we can actually set up an experiment and test. Now, I asked Sophia to do it earlier when she gave me her hypothesis. If we can phrase our hypothesis as an if-then statement, if this happens, then this will happen. If we phrase our prediction like that, it's going to be helpful. So here's some hypotheses. If you turn out all the lights, then you'll fall asleep faster. Could you test that? Sure. If you eat only fast food, then you will gain weight. That's a hypothesis. You can test that. So a good hypothesis, okay, has to be testable. It's always a sentence. You can never have a question mark at the end of your hypothesis because it's not a question. The problem is a question. The hypothesis is a statement. And also it's based on what you've learned. It's based on some background research you've done. You don't just sort of make a random guess. You make an educated guess about what you think is going to happen. So let's look at some examples of some hypotheses here. If a plant receives fertilizer, then it will grow larger. Is that a hypothesis? Could you set up an experiment and test it?
Yes.
Yeah. If you were, what would the independent variable be in that experiment? If plants receive fertilizer, then they will grow larger. So think about that experiment. What's the independent variable? The one thing that would be different between your groups. Derek?
Fertilizer?
Yeah, whether or not they got fertilizer. You have like two groups of plants. One gets fertilizer, one doesn't. That's the independent variable. What would you measure? What would the data you would be collecting? The dependent variable. Jordan?
Grow larger.
Yeah, the growth of the plants. We'd measure the plants. Underline that. That's the dependent variable. What about if I put fenders on a bike? You know what fenders are? Those little plastic strips that go above the tires.
Oh,
Yeah.
If I put fenders on a bike, then they'll keep the rider cleaner. Is that a hypothesis?
Yes.
Could we test it?
yeah.
Yeah, if you like got a bike and you go ride through the woods
Yeah.
with fenders and without fenders, and you see how dirty they are. All right, what's going to be the independent variable? Independent variable. How about some people I haven't heard much from today? Any new volunteers want to answer one of my questions? All right, Grace.
Fenders?
Yeah, whether or not your bike has fenders. You change that. That's the independent variable. What would the dependent variable be? What would we be measuring? What data would we be collecting? Trista?
Rider's cleaner.
Yeah, how clean the rider is. Good. If I study more, then I will get better grades. What's the independent variable in that experiment? David? Study. What's the dependent variable in that experiment? Savannah?
Better grades.
Yeah, the grades. Do you sense a pattern here?
Yep.
Yeah.
When we phrase our hypothesis as if this, then that, what's always in the if part? Aiken?
If like
Which variable is always in the if?
so
Look, if you look at all these examples, which variable was I circling that's in the if?
Timor.
That's the independent variable. So the independent variable is in the if. What's in the then? Rihanna?
A dependent variable.
The dependent variable is in the then section. So we don't have to do all these, I know it's repetitive, we get the point. But all of these, the if part contains the independent variable, and the then part contains dependent. All right, last thing for today. Let's look at an example. New experiment. Farmer wanted to know if music would make his chickens lay larger eggs. Does anybody keep chickens in their house for eggs? No? Yeah, I think it's becoming more and more popular. Anyway, so we took two groups of chickens, placed one group in a pen with music, one group was placed in a pen with no music. All right, so is that an experiment?
Yep.
Sure. Okay, what would the independent variable be in that experiment? The one thing different between the groups. Robert?
They had no music.
Okay, so what was different about the two groups of chickens?
Well, the first group had music, but the other one didn't.
Good, so the difference was music, right? That's what was different, good. Okay. What about the dependent variable? The data they collect. So what data are they going to be collecting in this experiment? Jenna?
The amount of eggs and chicken lays.
Not quite. If you look carefully, what were they testing? Not the amount of eggs, but something else about the eggs.
Larger.
So the size of the eggs, right? That's what they would measure. Okay, which is the control group? In this experiment, which pen is the control group? Nathan?
Control group. The control group is
So we have two groups of chickens, right?
yeah.
One has music played for them and one doesn't have music played for them. Which group is the control group? Which of those two?
Music.
What are,
No, the one not with the music.
right, because do chickens normally listen to music?
No.
Not as far as I know. So the control group, where the chickens are treated normally, is this one without music. So what's the experimental group? Yeah?
The ones with music.
Yeah, the ones with the music. What was, do you have a question, Nathan?
There's a Looney Tune about this.
Oh, really? Did it work? They play music for the chickens? Interesting. Okay, last thing. All right, so we have our two pens. We have our chickens. One's getting music, one's not getting music. What are some of the variables we would want to hold constant between my two pens? Some variables held constant. Give me one, Ava.
Food.
The type of food the chickens are eating. Give me another one, Claudia.
The same amount, like the same kind of chicken.
Same type of chicken, yes. How about another variable they'd have to keep constant? Sophia?
The amount of water the chicken.
The amount of water. Mia?
The same area.
Same amount of area. Yeah, we could keep going with a huge list, but that's just write a few of them down. Okay? Everything's going to be the same if this is a good experiment. The only thing we want to be different is the music being played. You guys feel pretty good about the variables and the groups?
Yeah.
Over the next few days, we're going to be doing lots of examples. We're going to be doing our own experiment where you're going to have to identify these things. Okay? Probably we'll be looking at a quiz next week. Early to middle of the week, I would say. Middle of the week. All right, have a great day.
Thank you.
You're welcome.